Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And I'm Graham. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284, and an email at dothemath@kern.org. We're online at dothemath.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, thank you for doing that. So, Graham, where do you go to school and what grade are you in?
I go to Stockdale Elementary and I am in 6th grade.
Oh, 6th grade.
Good.
Is there anything that you think you'll miss about the school you're at because you're going to go to a brand new school next year?
Probably
Or-
the routine we're in every day. That kind of things. Yeah.
Okay. So is there anything that you're looking forward to?
Probably just switching classes. Seems like more of a change.
All right, yeah, well, it certainly will be. So you're going to have to get used to all those different classes and all those different instructors and make sure that everything's cool in all those classes.
Yeah.
All right. So what kinds of things are you working on in your regular classroom as far as mathematics go?
We started exponents today.
So you started exponents. Oh, good.
Yeah.
Well, maybe we'll do a little bit of exponent work today since you just started it. Is there anything in class that you've done so far this year where you think you could use a little bit of extra help?
Not yet.
Okay, so everything's been going pretty smoothly.
Yes.
Whenever you do something, you're kind of grasping it, you feel pretty good about it, and you're ready to move on?
Yes.
All right, good. Well, we'll take a look at those exponents a little bit later on.
Okay.
Right now, I need you to help me out with a social media problem of the day.
Okay.
All right, let's take a look at that. Here it is. It says 15 minus 9, funny you should say exponent.
I know, I was going to say the same thing.
And divided by 7 minus 4 with an exponent. So first of all, Graham, can you explain to me what those little 2's are and why they're written in that manner?
The small 2's are to signify that the number would be cubed, which is meaning it's multiplied by itself.
Close. So it's squared.
Oh.
When it's raised to the second power, it's squared. When it's cubed, it's raised to the third power.
Okay.
Okay? Because when you square something, when you want to find the area of something, you multiply the length times the width.
Yes.
2 dimensions. If you want to find the volume of something, you're going to go length, width, and height.
Yes.
So that's 3 dimensions, which is why you're going to cube it. Just one way to think about it. All right?
Yes.
So you're going to take a number and multiply it by itself, is what that exponent means?
Yes.
All right, so let's take a look at the first part of it. What do you think that is?
15 minus 9. I assume since it's in the parentheses, we would do that equation first.
Okay, and what is that?
That would be 6.
Okay. Then what we'd like to do?
We would square the number, but square the answer we got, and it would be 6 squared.
Okay, and what would that be?
That would be 36.
Okay, so it's not 6 times 2.
Yes. Wait, no.
Okay,
Yeah.
good. That's what, making sure you're on track there. Right? You're 100% correct so far. I'm just trying to make sure that you are confident in what you're doing. So we have 6 to the second power, which is 6 times 6, so it's 36.
Yes.
Then what do I do?
Then you would, in the other set of parentheses, subtract 4 from 7, which would be 3, and then make that an exponent.
So what's that all going to be now?
That would be 9.
So you said that would be hesitant 9. So are you sure it's 9 or could it be something else?
I think I'm sure it's 9.
Okay, so you think you're sure it's 9, okay. So if we have 36 divided by 9, what would the answer be?
36 divided by 9, that would be 4.
So you're pretty confident that it's C?
Yes.
If I went 15 minus 9 and I got 6, and I went 6 times 2 is 12, and I went 7 minus 4 is 3, 3 times 2 is 6, 12 divided by 6 would be 2, wouldn't it?
Yes.
And that could be A.
Yes.
You're still thinking that it's C?
Yeah.
All right, let's take a shot and see how you did. All right, it's a good thing we stayed with yours, right? There you go, first problem done. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to deal with football. So are you a football fan?
Yes.
NFL football fan? Because there's a lot of different football.
Yes.
All right, so do you have a favorite team in the NFL?
No, not really.
Not really?
Not-
Is there anybody
not
that you
really.
kind of follow, or do you have a favorite player and they happen to be on a certain team, or?
I like the Dolphins quarterback.
You like the Dolphins quarterback, Tua?
Yes.
All right. And why do you like Tua? Just out of curiosity, isn't it?
Because he played at Alabama.
Ooh, there you go, son. You going roll tide, huh?
Yes.
All right, roll tide. You know what, dude? You're going to do fine today. Fine today. All right. And he's got Waddle on there,
Yes.
who went to Alabama, right? There are a lot of
Yes.
Alabama players on that team. All right. So anyway, I do think that Miami had to go to a cold weather city this last week, didn't they?
Yes.
And they don't do so well in cold weather.
Yes.
And it's not just Tua and the Miami Dolphins of this year. I don't think they have ever, in the history of the Miami Dolphins, won a game under 40 degrees.
Yes. I feel like I heard that before.
Yeah,
somewhere.
yeah. So I mean, they're warm weather Finns down there, and they like it
Yes.
warm down there, right? I can't argue with that. So today's Math in the News, because this last weekend we had a couple of record-setting games. So the first one that we're going to talk about is the game must go on. So it was Kansas City and Miami, and it was -4 degrees Fahrenheit. That's pretty cold,
Yes.
right? Because when you get to freezing, right, 32 degrees, that's freezing.
Yes.
Right? So if freezing is 32 and we're at -4, how many degrees did we move altogether?
36
There you go. Good. I'm just putting you on the spot a little bit right there, making you do some math right now. With a wind chill factor of -27,
Yes.
even colder now, isn't
Yes.
it? Have you ever been in a cold climate like that?
Not that cold.
Not that cold, but you've been in cold before?
Yes.
Have you been someplace where it's been snowing or it has snow on it?
Yes.
Oh, good. All right. So we can see in the photograph here, that's a photograph of Buffalo when they were getting ready for the game. Oh, okay. So I guess it's not showing up technically, but anyway, so they had to shovel out that stadium
Yes.
in order to be able to sit there and watch the game. So the other one was the Buffalo Bills and the Pittsburgh Steelers. Now, both of those guys are used to cold weather all the time.
Yes.
Right? So 18 degrees Fahrenheit with winds around 10 miles an hour makes it feel like 4 degrees. So now let's take a look and see, how do they get wind chill? All right? So when it's summertime and you have a fan blowing on you,
Yes.
what is that doing to you?
It cools you down
It
so
cool-
you can.
Right,
Yes.
it cools you down, right? It's taking your body heat and removing it, moving it off of you, right? So the same thing happens with a wind chill. When you're outside and it's already cold, that wind blowing on you is going to make it feel even colder than what it actually is.
Yes.
Does that make sense?
Yes.
So that's the wind chill, right? And obviously, the faster the wind, the colder it's going to feel.
Yes.
And we can see here, so let's say it's, what was the one, -4 degrees, I think is what it
Yes.
said, right? So we can go right here, and let's just say it was -5, all right? And with a mild breeze at 5 miles per hour,
Yes.
right, it would feel like it's -16. So you see how we're reading this chart here?
Yes.
Okay? And you can see that frostbite is going to happen in a matter of time if your skin's not protected.
Yes.
After a certain amount of time, it can be pretty harmful to be outside in temperatures like that. So you can see how this kind of moves pretty quickly as far as the wind speed. So if it's -5 and it's a mild breeze, we've got -16.
Yes.
But if the wind is really going, it can jump
Yeah.
pretty quick,
Yes.
right? So now you know a little bit more about wind chill and stuff like that, all right? And that is today's Math in the News. 636-4357 is that phone number. Graham is a 6th grade student from Stockdale, and he's been working in class on exponents. We did a little bit about that with our social media problem of the day. But right now, we're going to see how art and math go together.
Welcome back to Do the Math Art Day, and today we have Lorraina from the Bakersfield Museum of Art. Thanks for coming today. So today she has a fun project planned for these kids, so can you tell us a little bit about it?
Yeah, so we're going to be making a paper collage. We're making a pizza. We're going to be using fractions. So an example I have here, we're going to divide it into parts. We have some paper here we're going to cut out to create the toppings to our pizza, and we're going to fill it in as we go along. We're going to have the first one we're going to do together to make the hole. We're going to make the circle for the pizza, and then we're going to add cheese to it. We're going to look at our paper and see how much of it's going to be onto it. Then for, say, pepperoni, I'm going to have 4/6 of pepperoni. So I'm going to look at my pizza and fill it in as I go along. 3/6. I'm going to fill in 3 of the parts, and 1/6 maybe for the mushrooms and sausages, and then we'll going to have our box to put in our pizza.
All right, so each of the kids right now, they're going to start by drawing a circle, right?
Yes.
So you guys go ahead and draw your circle on your page. And we'll all have our same crust, and then we'll all add our red sauce,
Our
correct?
topping, yes, our-
Next. And then once we get the pizza drawn, because we're splitting it up into 6 parts,
Yes.
right?
Yes.
So they split up their circle first, or add their sauce first?
We'll add the sauce and then the cheese, and then we'll start taking it apart into pieces.
Okay,
Yeah.
so once you guys have your circle, they're gonna cut that out?
Yep.
All right, so if you guys have your circle drawn, go ahead and cut out your circle shape for your pizza. Good, and you already have yours broken in? All right, good. And then once you get that one cut out, you guys can also, they're getting to make their own fractions, right?
Yes.
So you guys will be able to fill in your own fractions if you want 4/6 pepperoni, 1/6 pepperoni. If you want 0.6 olives, I don't know, you might not like olives. All right. Good. And some of you guys already have your fractions figured out, right? Oh yeah, we got yours. You like sausage on yours? And olives, I see. Good. All right. What's up? So, okay, so once we get this, we're going to start with your red sauce. So once you get your pizza cut out, go ahead and grab your red piece of paper. And we will cut the circle for the sauce. Does everybody have red? All right, you need some here. Is this the one for the red sauce?
Yes.
Okay. So you have to make your sauce fit on
So
here.
another circle. You probably want to use the sides as well.
There you go. And make a circle out of that one. All right, so we're gonna continue on here, get their pizzas made, and then we will see you guys back once they got more toppings on there. All right.
All right, thanks for that, Sam. And Lorraina, also thank you for coming in from the Bakersfield Museum of Art. In studio, we've got Graham, and you like pizza?
Yes.
You have a favorite type?
Pepperoni.
All right, we'll talk a little bit about that more in a little bit. But first, let's take a look at one of the problems that you're going to be working on. I do believe you have this as a homework problem tonight.
Yes.
So it says, find all the rectangular configurations that can be made using 6 large squares and 4 small squares with a certain number of rectangles. All right. Now, above that, it says the length, one is a large square tile, the second is a small square, and the third is a rectangle. The length of the rectangle is the same length as one side of the large square. the width of the rectangle is the same as one side of the small square. So you can make up whatever dimensions you like. I would assume that the smaller numbers you work with would be the easier ones to work with. Okay? So you and Cece are going to work on this, and you must use 6 large and 4 small squares. So head on over to the board. So you must have 6 large squares, 4 small, and then it's up to you how many rectangles you use.
Okay, so I'm just gonna make some little notes for ourselves so we know we've got our littles, we've got our bigs, and then we've got these rectangles that are the same width here and then the same length here. Maybe that'll kind of just jog our memory when we need it. So go ahead and grab a pen and kind of start talking me through what it is you want to do. So I understand he told you originally to kind of pick how many rectangles you wanted to use. So you had a thought on that.
I thought we can use 6 large rectangles.
Okay, so if you were going to use 6 rectangles, that works for me. I don't know what your plan is, but go ahead and let's start kind of playing through that and we'll see what happens.
So, do I just write 6 rectangles?
Well, let's start kind of drawing it out and see what happens.
If I use 6 rectangles like this, okay, 6 might be too many. So,
Why do you say that?
because I don't know if there'd be enough space on here.
Oh, I see what you're saying. So you're
Maybe I
worried
could
about our
draw more,
space.
yes.
Okay, so then if you decide 6 is too many, let's pick another one.
We could do 4.
Okay, fine. So let's see what 4 might look like. Okay, so we know that ultimately our shape has to be a rectangle. So if those are our 4 rectangles and you've lined them up that way, what are we going to do with our 6 squares and then our 4 little squares?
We could place the 6 squares along this, like evenly, parallelly pair them up with the...
Okay, so if we had 1, 2, 3, 4 of the large squares, where are the other 2 large squares going to go? What are you thinking?
We could put them down here, possibly.
Okay, so go ahead and give us the 4 big squares.
And then 2 more.
Okay.
One right there, one right there.
Okay, so now we kind of have this gap, and we need to figure out how to do the 4 squares here, yeah?
Yes, and it said 4 squares needs to be approximately the same size as...
So actually what happened here is that we haven't really completely defined what our length and width is for each of these objects, though, either, have we? We just know that this length is the same as this length is the same as this length, but we don't really have a relationship here, so maybe we need to think about that. So how many little squares do you think fit in a rectangle? How many do you want to say fit in a rectangle?
Probably 3.
So we want to say 3? Okay.
Possibly
3?
2 or 3, yeah.
Okay. Now I'm going to suggest, I'm just going to make a suggestion. Because we have 6 and because we have 4, 3 seems like kind of maybe a strange number to throw in there just because it doesn't, like, the 4 and the 3, we're not going to be able to like get 4 squares to match up with the rectangle. So maybe the 2 or 2. Okay, so let's go with 2. So let's go ahead and make this, we'll give it a little. Okay, so if that's a 2, then we know we have 2 here, right? Mm-hmm. Okay, so if we know we have 2 here, how many little squares are in this then?
I believe 4.
How do you know that?
Because it said 2 little squares are the same length as 1.
Mm-hmm. And this is a square,
Rectangle.
right? So if this is 2, then this has to be?
4.
Well, this has 2
never
and this is 2 for a total of
Yes.
4. Okay, so
Yeah.
you can go ahead and draw 4 in there so we have a little bit more of a reference. Okay, nice. So now, if we look back at what you drew, and we currently have 6 large squares, and we know that we can only use 6, and we need to use the 4 small squares. Let's do our 4 small squares.
Okay, so that's 4 small squares. Okay, so maybe 4 rectangles doesn't quite give us this full rectangle because we still have this space right here, right?
Yeah.
What could we fill in there? Now that we've used our 6 large, we used our 4 small. What
Do
could,
2 more medium
well,
size.
let's go ahead and do that. How many rectangles did you originally say you wanted to use?
6. Yeah.
Awesome, I like it. So that's one option, right?
Yeah.
That's one option right there. You want us to go further with that?
Well, what I was going to say is you can leave that right there because that's one configuration. So what would the dimensions be of that rectangle right now?
2, 4, 6, 8.
Okay, I'm gonna go ahead and I'm gonna do it in a different color. Okay, so that's 8.
Yeah.
And then
8,
we say this is,
10. Wait, no. 6.
so 2, these are our length of 2.
2,
This is length, what's the length of this?
1.
1.
2. So 5.
Okay.
Okay.
All right.
So the total area of that rectangle is what?
Go ahead and
so
you put it there.
40, I think.
Right, so it would be 40 units
Squared.
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 Yeah, so
Right.
go ahead and give us our u squared. Just right next to the 40. So u,
Okay.
yes, squared. Cool. I
There you
like
go,
it.
that's all you need,
All right, I
40
like that.
units squared.
Okay.
So my question to you is, if you made an 8 by 5 and it came out to be 40 units squared, is there another way to configure all of those pieces to make another 40? That's what I want you to work on in a bit. But before we do anything else, I'd like to award you with a certificate to go to any Cal State sporting event of your choice. So I'm glad that you seem like you like sports, right? So
Yes.
you like football, and I believe you have your Cubs shirt
Yes.
on underneath that, right? So you're a baseball fan? There you go. All right. Well, I know CSUB has a baseball team as well as many other sports. So you've got plenty of options to go to as far as that goes. Right now we are going to, have you ever done scientific notation? Do you know what that is?
Isn't that what exponents is?
Ooh, maybe we'll find out right now.
Hi, my name is Mikaela Renee Jimenez, and I'll be teaching you guys how to do scientific notation into standard form. So for example, we'll be having 2.5 times 10 with the exponent of -9. So to turn this into a standard form, we'll get 2.5, and we'll be moving the decimal 9 places. But to the left because it's an exponent. It's a negative exponent. So we'll be moving this decimal to 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll put a decimal right here, and then we'll put 0 right there. And then we'll fill all these placeholders with zeros. And this will just equal out to 0.00000000025. And then we'll be going on with the positive exponent since we did a negative one. So with the positive exponent, we'll be doing 2.75 times, let's do something easier, 10 with 3. So we'll be turning 2.5, oh no, 7.5. And then we'll be moving the decimal to the right. Since it's positive, we'll be moving 1, 2, 3. We won't have a decimal because we don't need one right there, and we'll just fill this placeholder with a 0, and that would equal out to 2,750. And then that's how you do scientific notation into a standard form. And then to put standard form into a scientific notation, we'll get 2, 4, 5, 0, and 0, 0, 0. To put this into a scientific notation, we'll get 2.24500000. We'll get what the first 2 numbers. we'll get a decimal right there, and we'll move it. We count how many places it takes to get all the way to right here. So we'll get 1, 2, 3, 4, 5, 6 times. So that means it will be 2.45 times 10 with the, since it's going right, it'll be positive, so it'll be positive 6. And that's how you do positive scientific notation, standard into scientific notation. To do it into a negative scientific notation, we'll get, for example, 0.000045. To turn this into a positive, we'll get, put a decimal right here, and we'll be placing it all the way, because we gotta get the first 2 numbers. We'll place it all the way over to this way. So that would equal out to 1, 2, 3, 4, 5, 6 times. So it would equal out to 4, since we have the decimal right here, 4.5 times 10 with a negative, since it was going right, not right, left, would be negative 6. And that is how you guys do scientific notation. Thank you.
Nicely done with scientific notation and using those exponents. Funny that you said you're working on exponents in class. First problem we do just happened to be the social media problem of the day, had exponents. You're dealing with exponents and scientific notation. You're going to do some a little bit later on. But right now we're going to go back downstairs, check in with Sam and Lorraina, and see how they're doing on their art and a little bit of pizza.
All right, we're back here. So Lorraina, let us know what the kids have been working on so far.
Yeah, so far they have their cheese part done, their whole. Now we're gonna go in and split up our pizza into parts using some of these lines that we have. We're gonna take apart the pizza, so an example here, she's ready in her parts that she wants. So an example, she wants 5/6 of pepperoni. She's gonna start cutting out the shape of a pepperoni and then adding them to her parts. Again, so she's just doing simple cuts. We have some circles for pepperoni, bell peppers, some mushrooms and sausage shapes.
All right, so let's take a look at, let's come look at everybody. Let's ask you about, so what kind of pizza are we gonna you're gonna make?
I plan to have it mostly mushrooms. I want to do a little bit of everything, and I also put cheese splotches rather than little strips.
I like that. So you have cheese sauces, and so you got 5/6 pepperonis, 3/6 bell peppers, 2/6 olives, 6 all over mushrooms. That's your favorite?
Mm-hmm.
All right. Okay, so let's see right here. So what do you got going on for your pizza?
I'm gonna do a lot of sausage and pepperoni, and I don't really like these 3. But
Yep,
that's
so
just
0
my personal,
olives, yeah.
That's my
okay,
personal preference.
That's all right, yeah. So yep, you've already got yours broken up, so now
Yeah.
you're ready to start moving on with yours. It's looking good. Okay, what about you going? You got,
My pizza is mostly gonna be meat. I don't like olives either. So
Okay.
no olives.
a lot of meat pizzas over here. Oh yeah, 6 out of 6 sausages and mushrooms. That
I
sounds
love
good. I like
mushrooms.
how you cut out your sauce.
Thank you.
Very good. All right, let's move over to our guys over here. All right, let's see your pizza. We have these, they have lots of cheese over here.
So this pizza is going to be a good pizza. It's going to have olives, bell pepper, pepperoni, and sausage. It's going to taste delicious. If it were not paper.
Oh, right, yeah, don't eat it. All right, you too, you have 0 mushrooms. All right, so you're ready to start cutting your strips so you can breaking it up?
Yeah.
Okay. But you could cut these and then it'll just have your straight lines too. That might be easier. Okay, what about you? What kind of pizza are you gonna make?
Just a little bit of everything, pretty much.
Okay. What's your favorite?
Probably pepperoni.
Pepperoni and lots
Yeah.
of cheese.
Mm-hmm.
Very cool. All right, and you're getting your fractions in. We have one more over here.
So I'm gonna be making like 3/6 pepperoni, 5/6 bell pepper, and 1 6 olives, which I'm already making right
Okay,
now.
yeah.
And then 2 6 mushrooms and 6 sausages, since I really do like sausages.
Sausage your favorite?
Yeah.
All right. And so you gotta, before you do all those, you're gonna just start adding your strips.
Yeah.
Break up your pizza in 6s.
Mhm.
All right. All right, so now we got everyone's breaking it up into fractions right now and slowly starting to add on all of our toppings. Do you guys have the papers that you need? You guys have everything? All right. There we go. You need it a little bit thinner on yours? Since yours is so tiny, you might want to do your little strips a little bit smaller.
Okay.
That way you have more space for your pizza, right? There we go. See that?
It doesn't really fit on though.
That's okay. It's just, if you see hers, well, yeah, hers actually did go all the way across. So you guys said you guys have names for your pizzas?
Yeah.
Yeah.
What's your name of your pizza?
Mine's Bob.
Bob the pizza. All right, and what was yours?
Mine's Terry.
Terry the pizza. And what was your pizza's name?
Fred.
Fred. Yeah, there's 2 Freds. I think his was Fred's too over here. Did you have a
Fred
Fred?
is delicious.
All right. And Fred has some 3-dimensional going on, right?
Doozy.
Well-
It's still paper.
Well, but it's sticking out, so that makes it 3-dimensional, right? So you're having a little bit of some form. We got some texture going on, right? You guys know the elements of art? What are the elements of art?
Texture, distance.
Color, line, shape, space, form, texture, value. Right?
Wasn't there also distance?
No, well, space has distance.
Oh, yeah,
That's in
space.
like if you have foreground, background. So you guys have color, right? You have line. Yeah, your drawing's line. You have shapes. Yeah. No, not really. Well, I guess there is some space because you have like your cheeses in your foreground, your sauces in the midground, your pies in the background. Your pie. Isn't that what you call the pizza crust? Is your pie crust, right? So color, line, shape, space, form. You definitely have texture, and not really much value.
We have cheese.
You do have cheese, lots of cheese. Good. You guys are doing a good job. You got yours broken up. How you girls doing over here? Good. Got your pepperonis all on there? Not yet. You're still working on your cheese. It's looking good. We need to add like some little specks on our sausage, right? Or our cheese.
Yeah.
All right. So as these guys are finishing up right now, right, we're going to come back one more time and we'll see how they're doing on their pizzas. So far, they've done a good job mixing it all up.
All right, well, we'll go back and check with those guys in a little bit. Nice to see that they're progressing nicely on their problem right there. All right, we do have Graham in studio, a 6th grade student from Stockdale Elementary, working on area, and right now you have the 8x5 and you got to a total area of 40. You need to take all of those different shapes that you've got, making sure that you use the 6 rectangles again, and see if you can come up with another way to make an area of 40.
Okay, so we originally had it as an 8x5. So the question really kind of becomes, what are other ways to do an area of 40? So maybe we want to make a list first. Let's make a real quick list of different ways we could get to 40. So how could we get to an area of 40? You can go ahead and take your...
We obviously have to do the 6. So
I'm not drawing yet. Let's just go ahead and think about just area in general. We know it's a length times a width, right? So multiplying what times what gets us to 40?
Okay. We would start by 1 times 40.
Okay.
2 times 20.
Okay.
4 times 10. And 5 times 8.
Okay. Okay, so I'm going to ask you, do you think we could make a rectangle, a 1x40 rectangle, using these shapes?
Possibly.
Possibly. Okay, so I'm going to say there's probably, okay, you say doubtful. Tell me why maybe doubtful. What shape's going to throw us off for a 1 by 40? Tell me the area of each of these shapes again. This is a what?
4 by 4.
Oh, this was
2 by 2.
right. So it's a 2 by 2. So we already have
2
this.
inches.
Right. We already have a 2. So we can't do a 1 because we got to use them, right?
You would have to get to 20.
Okay. So we know that this one's out. Okay. So we say, okay, this one's out. This one we already did. So here are 2 options, right? Mm-hmm. Okay. So what can we do?
Well, we can utilize the 4 by 10.
Okay. How would we use the 4 by 10?
We could possibly stack 2 large squares on top of each other.
Okay.
Making 4.
Okay, so go ahead and let's try that real quick and let's see what kind of happens there. Where that works, maybe if it doesn't, we don't know yet. Okay, so that gives us our length or our height of 4, and now we need the length of 10. So this is our 4. That's already a 2, so let's keep going. Okay.
Could make more of these. And that would obviously be our 6 that we can use.
Okay, nice. I like it.
Yes.
And then?
And then that, we'd be at 6
Okay.
units.
Yep.
So we could add 4 more small rectangles or squares.
Okay, so there are 4 squares. Okay.
And that would be 1. So we'd be at 7 units.
Okay.
Then we would add 2 longer ones on one side.
Okay, so I'm going to go ahead just because you've said it,
yeah.
but then that way we don't have to keep going back. Okay, we got that, yeah? So what is
8.
that, 8?
And we can do this 2 more times, resulting in 4 by 10.
Okay, so that seems to work out pretty well. So that gives us another 1 and another 1
Yes.
for a total length of 2, 4, 6, 7, 8, 9, 10.
Yes.
So 4 by 10, and we have used our 6 bigs, our 4 smalls, and our 6 rectangles. So that looks pretty good.
Yeah, nicely done. So you got
Sounds
the
like
4 by
that.
10,
Yep.
and you know that there's a 2 by 20, and you think that's a possibility of actually making a 2 by 20? Because let's go back to the original problem. We'll take a look under the camera right here. And you determined that you wanted to use 6 rectangles, which was good, right?
Yes.
And you've already made 2 of them. The very last thing says, illustrate all the different configurations that can be created, and how do you know? Explain how you know you got them all. So I think by doing what you did right there, by figuring out, all right, what are the different possibilities, and saying you cannot do a 1 by 40, but you did do the other one, and you got the second one, and if you were able to make a 2 by 20, you satisfied all of those, right?
Okay, now if we look at this super fast, do you think we can do the 2 by 20? Just a yes, no?
No,
You don't think so?
I don't think so.
I think we can,
Okay.
and here's why.
Just draw your, yeah.
Because if I take this half and I brought it down and just laid it across there, I would have a 2 by 20.
Yes.
Love it.
There you go, nicely done. So therefore you got them all right? And hopefully that helps you out with your homework right there, and any other students that are working at it as well. Right now we're going to find out what's new at NASA this week.
Rollout of our experimental supersonic X-plane, schedule updates for future Artemis missions, and another year of global record heat. A few of the stories to tell you about this week at NASA. On January 12th, we officially unveiled the fully completed and freshly painted X-59 aircraft during a rollout ceremony hosted by Lockheed Martin Skunk Works in Palmdale, California. The X-59 is a one-of-a-kind experimental aircraft that, as part of our Quest mission, will demonstrate the ability to fly supersonic while generating a gentle sonic thump rather than the typical loud sonic boom. For more information about Quest, visit nasa.gov/quest. NASA has adjusted the schedules for our Artemis II and Artemis III missions. Artemis II, the first crewed Artemis mission around the moon, is now targeted for September 2025. Artemis III, which is planned to land the first astronauts near the lunar South Pole, is now being targeted for September 2026. The schedule adjustments were made to allow teams to work through challenges associated with first-time developments, operations, and integration. According to an analysis by NASA, Earth's average surface temperature in 2023 was the warmest on record. Global temperatures last year were around 2.1 degrees Fahrenheit above the average for NASA's baseline period of 1951 through 1980. Independent analyses by NOAA and the United Kingdom's Hadley Center concluded the global surface temperatures for 2023 were the highest since modern record keeping began. For more about NASA's Earth science efforts, visit nasa.gov/Earth. Astronomers using our James Webb Space Telescope have discovered a new, previously unseen structure in the Beta Pictoris system about 63 light-years from Earth. The structure is a branch of dust shaped like a cat's tail. It extends from the system's secondary debris disk that has been produced by collisions between asteroids, comets, and planetesimals. This and other NASA news was featured at the 243rd meeting of the American Astronomical Society in New Orleans. And that's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
All right, always exciting things going on at NASA. Are you into NASA at all, space and stuff like that?
Not really.
Not really?
No.
All right, well, everybody's got their thing, and sometime maybe in the future you might be like, it's pretty cool. Otherwise, you might be like me, and I'm like, not really. Have you ever seen Star Wars?
I've seen the first one.
How many are there? Do you know?
I believe at this point there's 10.
How many have you seen?
11? All of them.
Oh. All right, good.
A few times.
I think I saw a good majority of the first one, but that's about it. And I think I've seen bits and pieces of other ones, so the Star Wars marathon, I don't think I'll be going on anytime soon. Anyway, Graham, you said that, got the, on that one. Must be Star Wars fans in the back then, I guess, right there. All right, so you said that you've been working on exponents in class right now.
Yes.
And you just kind of started with it.
Yes, today.
All right, so why don't you head over to the board? And that's funny, started today. All right, good.
Okay, so show us what you know.
Yeah.
Give us an example and show us what it means.
If it says turn 3 times 3 times 3 into an exponent,
okay,
you would need to simply add to simplify it, you could count the number of 3's in the equation.
Okay.
And it would come out to 3. And you would write the number of 3's in this little corner right there.
Okay, good. I like that. So if I give you something like 5 times 5 times 5 times 5, how would we write that one?
We would write that 5 to the 4th.
Okay, good. So this number right here ultimately tells us what?
How many times you're multiplying it.
Perfect, I love it. So how many times you're multiplying that? Do you know what word this is? What is this called?
It's the base.
That is the base, excellent. So that's our base, and that of course is our exponent. Very good. Okay, so if we know this, let's move on and we'll just start. We already did something like this. And how do we say that?
We would write that.
No. How do we say it?
3 to the 2nd.
Which is also 3
squared.
Squared. Okay, just like we were talking about earlier, that's because it's in 2 dimensions, right? So it's a square. It's a 3 by 3. So what's my answer for 3 squared?
9.
9. Go ahead and give us a 9. Okay, so if I were to do, which you already kind of did this, you did 3 to the 3rd, which is also 3 cubed, okay? Because it's in 3 dimensions, right? So we have a length, a width, and a height, right? So 3 dimensions, okay? So what is the answer for that one?
27.
How do you know that?
Right?
How do we know that?
Because if you multiply 3 times 3, that's 9, and 9 times 3 is 27.
Good, so we know that doing something to an exponent, it grows really fast, which is why it's called growing exponentially, right? So when
yes.
something grows really fast, we're like, that's exponential growth because it grows really fast. Because if we take 27 and multiply it to another 3, we're going to get to 81, right? And it's going to keep growing really fast. Okay, so we have our base, we have our exponent, and we know that it means that we're multiplying it by itself multiple times. Let's do this. If I were to ask you 5 to the second, or 5 squared, times 5 to the 4th power, could we simplify that, do you think?
Yes. We could solve it as 2 separate equations.
Okay, right, we absolutely could. We could figure out what 5 to the 2nd power is. What is that?
25.
25, okay. And then we could do 5 to the 4th power, whatever that is, right? Okay, we could figure that out. But I'm going to say, let's go ahead and simplify it and say this is going to be 5 to the what power?
6th.
How do you know that?
Because if you add the 2, then it's the 2 exponents, then that's...
Why are we adding the exponents? That's multiplication. You're right. Don't second guess yourself. Let's think about why it is that we add our exponents when we multiply. What does it mean to do 5 squared?
It means to multiply it by itself.
So it says 5 times 5.
Yes.
Right? Okay. What is 5 to the 4th power? Go ahead and show me. What's 5 to the 4th power? How do we do it? What does it look like? So it's going to be what?
5 times 5 times 5, and one more.
Okay, so how many 5s did we multiply?
6.
Absolutely right. So you know that it's to the 6th power.
There you go, and that's a nice next step based on what he has already learned with his first day of exponents right there. All right, we do have one more opportunity. We'll go downstairs and check in with the Museum of Art, Lorraina and Sam.
All right, hey, we're back. So Lorraina, let's check out these pizzas that the kids are making. Yeah. We'll start over here. All right, and we have, it's Anthony, right?
Yeah.
All right, you got some olives going on, and your pepperonis.
Yeah.
So what else are you working on? How much pepperonis you got? You got one more third to go, right?
Yeah. So I'm gonna have 3 6 pepperonis, and then after that, I'm gonna start working on the bell peppers.
Okay.
If I could get it up.
Yeah, it's looking great. Okay, yep. What about you? Oh, look at this. You got like, yeah, and you got your little texture lines. Nice job on your bell peppers. It's looking really good. What else do you have? You have mushrooms on yours after your olives? Mushrooms and some sausage.
Not a much.
Good. Yeah. All right. You got yours on there so far. I see your pepperonis.
I'm doing bell peppers right
Oh,
now.
I like how you're crossing them off. You got cheese done, pepperonis, bell peppers, no mushrooms, right? Okay. How's Terry the pizza doing?
It's doing great.
Yep. Got all 6 out of 6 olives. Now bell peppers.
Pepperoni.
Pepperonis, yes. Is that what I say? Olives? All right. Oh, you're almost done.
Yeah.
Got your mushrooms.
Yeah.
Now you're doing sausage?
Yeah.
That looks great.
Thank you.
Getting hungry. All right. What about you?
Fred is doing amazing.
Fred is doing good.
I am currently working on his bell peppers.
Very good. I like how tiny Fred is.
He is very small.
Yes, that looks great. So Lorraina, I'm so thankful that the Bakersfield Museum of Art does this. So what programs do you guys have that are for kids?
So starting February 3rd, every second Saturday, we do have a little workshop for kids. So they get to explore different mediums and learn about different artists.
Great. So do they do like painting and sculpting?
Painting, sculpting, yeah, collages.
Nice. Yeah, that's great. What about other programs you have?
So next Thursday is our winter exhibition. So we're gonna have 3 new exhibitions at the art museum.
That's great. How fun. Yeah. Good. All right, well, this has been really exciting. I love how you're able to incorporate math and art together. And all these great pizzas that are going. So they're all going to get a box, right?
Yes,
So they'll get a box to
put
go
in their pizza. So
and add their pizza in
we
there.
still need to build it.
Oh yeah, so cute. All right, so these kids are going to keep working on their pizzas. You'll be able to find their finished pieces on our social media. And I think that's it for today. All right, back to you in the studio, Mike.
All right, nicely done. Thanks for that, Sam. And also thank you to Lorraina and all of the folks over at the Bakersfield Museum of Art. And a big thanks to Amy. I know that she helps coordinate that every year that the museum helps us out with Do the Math. And I know that they went through a little extra effort to get the pizza boxes for the students, because when she goes, oh, we're doing pizza today, and I saw the box, I was like, ooh, I actually have pie in there. And she said, no. I was get my hopes all up, stuff like that. But anyway, so we were talking a little bit before about pie. You like pepperoni?
Yes.
Anything else, or is it just strictly pepperoni?
Pepperoni and less cheese.
Oh, less cheese. All right, so you don't like more. You like a little less on the pie. Do you like the pepperoni, just pepperoni, or do you like it where it's double baked, like it's really crisp?
I like it normal. I don't like it too crisp.
Okay, so you like normal pepperoni. Yeah. Have you ever had the large slice pepperoni, or just the regular size?
I've had the large slice.
Large slice?
Yeah.
Yeah, there you go. Get a big piece of pepperoni on there. See, what kind of toppings do you like on yours?
It really depends. I think pizza is something I could eat pretty much any day of the week and just kind of alter my toppings.
So if somebody said you're going to make a pie right now and we'll give you 3 toppings, what would they be?
I know you're going to hate me for this, but ham and olives and the dreaded pineapple.
Oh my gosh. You won't have to worry about Graham or myself probably bothering you with that one right there. So you can have all of that pie on your own. So the only thing I would say is regular ham or Canadian ham?
Canadian?
Well, that's a little better, a little thicker slice right there. All right, anyway, we're going to come back with more right after this.
Do you know where your water comes from? Most of California's water comes from our national forests. It is just one of many resources that positively impact people's lives, ones we call nature's benefits. These benefits include water for drinking, irrigation, and energy, wood for construction, fuel, and heating, jobs for ranchers, loggers, and outfitter guides, and recreation for all. Trees clean the air and capture carbon. Scenic landscapes contribute to physical and mental well-being, and public lands provide settings for us to strengthen family bonds, create lasting memories, and continue cultural traditions. Our national forests provide all of these natural benefits. However, they are threatened by a warming climate, drought, insects, and intense wildfires. So how do we ensure our forests remain healthy so that nature's benefits are available for generations to come? We can help by increasing volunteerism, by providing good citizen stewardship, and by showing support for investment in restoration. Together, we can ensure that our forests continue to provide nature's benefits.
As a child, my dad told me that this forest near our house, that we had owned it. As I got older, he started explaining that we owned it with other people. And eventually the idea of national forest was explained to me. I think that understanding that we actually own that, it really changed my life. I think that there's a disconnect between the public and the lands that they own.
Some people don't realize what the national forests offers them.
People are just forgetting to go and see these wild places.
One of the biggest problems facing our national forest is just awareness.
I don't think a lot of people are aware that it is their public land.
I think it's really easy to take national forests for granted because it's always been here for us.
I see it as our most valuable resource in this country, and as a citizen, I think it's our greatest right to wander and roam and be connected to this earth.
The thing I wish more people knew about national forests is just simply how incredible they are. They're life-changing.
You know, I'd have to say that my time and experience within the national forest has had a huge effect on who I have become.
The national forest means many different things to many people. My family can attest to the fact that after I get done climbing, I'm a happier, better person.
It's where I go to find my peace. It's where I go to reconnect with nature.
In national forests, I am completely present. It's one of the most important things for me when I need to disconnect from the rest of the noise.
It makes me appreciate everything else I have in my life. It leaves me with a sense of confidence that I can't get anywhere else.
It's in the national forests that you see the relationship between the land and the animals. It makes me feel alive. That's the feeling that I'm looking for in life.
When you own something, when you truly own something, you have an inherent responsibility to take care of that thing. That's in all of us.
To me, it's our shared lands, it's our shared heritage, and it's my responsibility to take care of it.
If we take care of it, it'll take care of us.
The responsibility that comes with being a steward of these lands, it shouldn't be intimidating. I think this is probably one of the greatest things that exists under the banner of what it means to be an American.
It's hard to really convey the value of national forests, but if you take a group of kids out there, it becomes pretty obvious. The looks on their faces, I mean, that's how you can understand the value of it.
Showing future generations to come that this is a place where you can go, and this is a place where you can heal. This is a place where you can grow as a person.
When I talk to my children about the forest and the importance, to me, it's everything that's good in this world and life. It's really a symbol of freedom, just seeing what the potential of humanity is. Go play.
Go discover.
Go beyond.
It's all yours.
That's what I'm digging too. Go out and play. National Forest right there. You like the outdoors, going outside doing things?
Yes.
Yeah, I think it's a lot of fun. There's a lot of people, they go, well, I like going outside. I like to be inside and do things, and everybody's got their thing. But I like going outdoors and doing things and going different places and just seeing what's going on. So, did you know what you are now?
I learned that I'm a Do the Math ambassador.
Oh, indeed you are. Ding, 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 because you were on the show before, so you know you are an ambassador. Yes. And you know you have an official uniform, correct? Let's take a look at that uniform right there. So hold that up, and we'll take a look at camera 3 right there. So that is your uniform. So do you know what it means to be an ambassador?
I know it means to spread news about things.
Right, so you're gonna spread the good word about Do the Math. You can do that, right?
Yes.
Okay, so did you learn a little something today?
Yes.
Good, I'm glad you did. I'm sure you learned more than one thing today, right? Did you have fun today?
Yes.
That's the most important thing right there. Do remember we have phone tutors most Tuesdays and Wednesdays throughout the regular school year. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.